The diagram shows a silo that consists of a cylinder topped by a hemisphere. The height of the cylinder is 17.5 meters and the diameter is 4.2 meters. And so here we have the diagram. Using pi as equal to 22/7, calculate the maximum volume of the silo, ignoring the thickness of the material used to make the silo. And so here we have to determine what is the volume of the silo. And so in order for us to determine the volume of the silo, what we're going to do is we're going to figure out what is the volume of the cylinder. So the volume of this cylinder, and then we're going to figure what is the volume of the hemisphere, and then we're going to add those two volumes to give us the maximum volume of the silo. Now, what is the formula for the volume of the cylinder? The formula for the volume of cylinder is pi r squared multiplied by h, where pi is equal to 22/7 and r is equal to 2.1. How did we get that? We got that because we got 2.1 because 4.2 is the diameter and the radius is half of the diameter. So the radius is 4.2 divided by 2. And so the radius is equal to 2.1. And so we have pi, which is 22/7, and we have the radius, which is 2.1. And then we have h, or the height, which is 17.5. And so we have 22/7, 2.1 squared, and 17.5, which is h. Next, what we're going to do is we're going to multiply all of them together. And when we multiply all of them together, we get 242.55 meters squared. And so that's the volume of the cylinder. Next, we're going to figure out what is the volume of the hemisphere. And the volume of the hemisphere is equal to 2/3, right? 2/3 pi r cubed. 2/3 multiplied by pi multiplied by r to the third power. That's the volume of the hemisphere, right? The hemisphere. So what we're gonna do is we're going to substitute. So pi is 22/7. We know that the radius is 2.1. And so we have 2/3 multiplied by 22/7 multiplied by 2.1 cubed, right? And so when we say 2 times 22, that gives us 44. When we say 3 times 7, that gives us 21. And we have the radius cube. So the radius cube is going to be 2.1 raised to the third power. And so when we multiply 2.1 raised to the third power times 44/21, we get 19.404 meters cubed. It's supposed to be meters cubed. That's definitely supposed to be meters cubed, not meters squared, meters cubed, because we're dealing with the volume. So meters cubed, okay? And so now that we know the volume of the cylinder and we know that we know the volume of the hemisphere, in order for us to figure out the volume of the silo or the maximum volume of the silo, we're going to add these two volumes. So we're going to say volume of the cylinder plus volume of the hemisphere. And that's going to be 242.55 meters cubed. So let's correct that, meters cubed. Okay, it's supposed to be to the third power, meters cubed. So we have 242.55 meters cubed plus 19.404 meters cubed. And when we add them together, we get 261.954 meters cubed. All right, so let's change this to the third power. And so our answer here is going to be 261 or 261.954 meters cubed. And that's the volume or the maximum volume of the silo. Next, we are going to determine what is the total surface area of the silo. And in order for us to determine the surface area of the silo, we're going to determine what is the surface area of the bottom, and then we can determine what's the surface area of this hemisphere. Now, we need to figure out what is the surface area of the visible cylinder. And the reason why we use the word visible is because not all parts of the cylinder is visible, all right? And so this part, right, this part, so the cylinder has two circles. If we were to, figure out like what's the cylinder made up of, it's made up of two circles, one at the top and one at the bottom, all right? And then we have this rectangular portion that is wrapped, right, which is this. So we have two circles, and then we have the rectangular portion that is wrapped, right? Now, the problem is that when we're looking at the surface area, we have to, we only consider the surface, right? The surfaces that we could actually touch, right? That are not hidden. The unfortunate thing is that this circle, one of the circles are hidden, right? One of the circles are actually inside, right? So this circle at the top here, right? This circle, we cannot include that in our calculations because this circle is not an external surface. It's not on the outside. We cannot touch it and feel it, right? It's on the inside, it's not on the outside, right? When we're dealing with surface area, we're talking about the external surface that we could touch and feel immediately as we touch the silo. And so, we only need to consider this circle at the bottom. So just like how we have the circle at the bottom, there's a circle at the bottom here. Let me draw that in. So we have to figure out the area of this circle at the bottom, right? And then we're gonna add that with the area of the rectangular part that is wrapped around. And so that's only two things that we're going to consider for the surface area of the visible cylinder. Only this rectangular portion that is wrapped plus the circle at the bottom. We do not include this. And so that means that it's going to be 2 pi r times h, because area of rectangle is going to be length times width. So we're going to multiply the two sides. So we take 2 pi r, we multiply that by h. All right, so we take 2 pi r and multiply that by h, and that's why we have this right there. 2 pi r multiplied by h plus pi r squared. That's the area of the circle at the bottom. Now, what is pi? Pi is 22/7. What is r? R is 2.1. As we can see, we just divide 4.2 by 2, and that gives us 2.1. So we have 2 times pi, which is 22/7, times r, which is 2.1, times h, which is 17.5. Then we say pi, which is 22/7, times r squared. Now, r squared is 2.1 raised to the power of 2. And when we perform this calculation, when we multiply all of this together, this side, we get 231 meters squared. Now, we could use meters squared because surface area is a two-dimensional measurement. So we could use meters squared. And then we say 22/7 multiplied by 2.1 squared. And so it's going to be 13.86 meters squared. When we add these two, we get 244.86 meters squared. But that's only the surface area of the visible cylinder. We need to figure out the surface area of the visible hemisphere. And so let's do that. The total surface area, okay, so we need to figure out what is the surface area of the visible hemisphere. Now it's important to note that the base of the hemisphere is not going to be included in our calculation. So we do not include this base. We only are referring to, we only are considering, right? This part, right? The part that is on the outside, right? Not the one at the bottom, not the base at the bottom. We're not considering that. And the reason why we're not considering that is because it's on the inside, right? That's the same portion here. It's on the inside. We're not going to consider that. We're only going to consider the portion that's on the outside, externally, that we can feel, that we could touch. That external surface is what is being considered. So if we're only considering that, then the formula for the area of that surface area of the hemisphere that is visible is going to be 2 pi r squared. All right, that's the surface area of the hemisphere, not including the base. All right, so 2 pi r squared, where pi is 22/7 and r is equal to 2.1 squared. I'm sorry, where r is equal to 2.1, but we raise it to the power of 2. So the surface area of the visible hemisphere is going to be 2 multiplied by pi, which is 22/7, r, which is 2.1, and we raise r to the power of 2. And so when we do the calculations, we get 27.72 meters squared. Next, what we're going to do is we're going to, in order to figure out the total surface area of the silo, we're going to add. So we add the surface area of the visible cylinder with the surface area of the visible hemisphere. So the surface area of the visible cylinder plus the surface area of the visible hemisphere. And when we add those two, we get 244.86 meters squared plus 27.72 meters squared. And when we add that, we get that the total surface area of the silo is 272.58 meters squared. And that's the answer for the total surface area of the silo. Next, we have to calculate the total surface area of the model given this information. The information that they gave us is that a small scale model of the silo is made on a scale of 1 to 20. So a small scale model of the silo is made on a scale of 1 to 20. Calculate the total surface area of the model. Now, if you want to figure out the total surface area of the model, what we have to do is we have to take the original surface area that we figured out, the total surface area of the original silo, and we have to multiply it by the scale factor. But it's very important which scale factor we're going to multiply it by. We're going to multiply it by the scale factor for the surface area. So once we figure out the scale factor for the surface area, we're going to take that and multiply it by the answer that we got previously, which is this total surface area of the original silo. Now they gave us a scale factor, which is 1 to 20, but we have to raise 1 over 20 to the power of 2, all right? So the scale factor for the surface area is going to be the scale factor that they gave us raised to the power of 2. And the reason why that's the case is because we're dealing with surface area, and surface area is a two-dimensional measurement. So we raise 1 over 2 to the power of 2. And when we do that, it's going to be what? 1 squared, and it's going to be 20 squared. And so what is 1 squared? Well, 1 squared is simply 1, and 20 squared is 400. And so we have 1 over 400 multiplied by 272.58. And so we take 272.58 and we multiply it by 1. And so we say 272.58 meters squared, all divided by 400. And when we divide it by 400, we get 0.68145 meters squared. Again, 0.68145 meters squared. So the total surface area of the model, this small scale model, is going to be this answer. And that's the answer to our question.